Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on binomial distribution word problems. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. The goal for binomial distributions and this PowerPoint is to compute probabilities, compute the mean and standard deviation, and classify a data value as ordinary or unusual. These are the three goals and the three things that you will probably be tested on here at Walter State. Before we begin, I want to briefly review the characteristics of a binomial distribution. To be a binomial distribution, there must be a fixed number of trials. Trials are independent. Each trial has two outcomes that we will classify as a success or a failure, and the probabilities will remain constant for each trial. Let's do a brief review of our distribution. In previous videos, I have covered in detail the reasoning behind the formula for finding the probability of a binomial distribution. When finding the probability of a binomial distribution, it's best to have a format or structure to use to help you keep up with your values and numbers that you will need. It is possible to do so without using this format or structure, but it puts you in a bind and leaves you a lot of room for errors. Using this structure will help you see things clearly. So let's look at that structure. And for Ms. Borlaug, it's a requirement. First of all, define your success. And then you have N, which is your number of trials, P, your probability of success, Q, your probability of failure, and X, the number of successes. And don't forget that a table is a very powerful tool. Label your X's from 0 to N, whatever your N is, and then we have our probability. And we have our formula for finding each individual probability. NCX is the count or the number of ways that we have it, N being the total, X being the number of successes we're looking for at that point, times P to the X, the probability of successes raised to the number of successes, times Q, and remember some teachers will use the 1 minus P instead of Q, but Q is your probability of failure raised to the N minus X, and the N minus X is just a way of saying the number of failures. If you have X successes, the rest N minus X gives you the rest or the number of failures. Let's jump straight to our example. Jeffrey likes to practice shooting hoops. He makes 74% of the shots. 8 of Jeffrey's practice shots are randomly selected. We'll find the probability that Jeffrey makes 6 of these shots. We'll find the probability that Jeffrey makes at least 6 of these shots. And lastly, we'll find the probability that Jeffrey makes at most 6 of these shots. First, let's verify that this is a binomial distribution. Each trial is a shot. So N equals 8, we have a fixed number of trials. Every time he shoots, it does not affect the next shot or the previous shot. So since randomly selected, we can assume independence. Success is that he makes the shot, so we have success and failure, and each shot has the same probability of 0.74. So we do have a binomial distribution since the situation meets all 4 characteristics. successes makes the shot. The number of trials is 8. The probability of success is 0.74. The probability of failure would be 1 minus 0.74 equals 0.26. The number of successes would be 0 through 8. Now we're ready to start the actual problem with Part A. Find the probability that Jeffrey makes 6 of these shots. This part asks us to find the probability for exactly 6. Here are our numbers that we had previously, and now we need a chart to keep up with our probabilities as we find them. Circle the value that you're looking for, in this case, exactly 6. Here is our formula. The first part of the formula is always the count, 8 being the total, and we want to figure out how many ways there are to put 6 shots made in 8 slots. So that would be 8, choose 6, times the probability of success would be 0.74, and we want 6 shots made, 6 successes, and since there are 6 successes, there will be 2 failures. 8 minus 6 is 2, so that will be 0.26, the probability of failure raised to the second power. When we compute that on the calculator, we get 0.3108. And again, Miss Borlaug rounds to 4 decimal places. Please follow your teacher's rules for rounding. And our answer is that 0.3108, since we're looking for exactly 6. The setup took a little longer than I expected, and we're reaching the 7.5-minute mark. I want to keep these very short and sweet, so I'm going to pause here and start the next video and pick up where we left off. Thank you for watching.